In this video, we are going to go over column aliasing and also calculated columns, literal values in columns, things like that. So let's go ahead and get a script to work with as a demonstration. You'll find this in your weekly learning module. It may not be the exact weekly learning module that you see me pull it from in this video. Some semesters we run different length course, so things get arranged a little bit differently. But you should have a script. Similar to this one. SQL alias calculated column. Okay, so what do we mean by an alias or a calculated column? Well, let me first adjust my resolution here. Take up a little bit more of the real estate, that'll be a little bit better. Let's look at an example. Okay, these are primarily talking about a select statement when we talk about column aliases and calculated columns. So in a select statement, we are not restricted to column names only from our tables. All right, so here we're dealing with a product category. So let's pull up that table over here on the left-hand side. We look at the columns in the product category table, and we have these columns. Okay, and we can include one or more of these columns, or all of them, in a select statement. But also in the select clause of the select statement, we can include literal values, such as this. Okay, values contained in quotes as strings. We can include numbers. Okay, we can include dates, things like that. These will be added to, appended to the current column values in the output. They don't change the actual data in the table, but they'll maybe format the output or add some additional data to the output. Okay, that's a calculated column. So here we're using calculation in kind of a non-mathematic sense, where we are adding a string value, product cat colon, to the name column. All right, so that our output is kind of formatted. All right, so if we execute that, we'll see that we get the product name, accessories, bib shorts, bike racks, but we have the literal value product cat colon in front of it. All right, this is kind of nice if we're maybe doing like a quick report with an SQL statement, and we want to make the data a little more descriptive or a little bit more friendly. Okay. We can also alias a column. So right now, when we create a calculated column, notice there is no column name. All right, we created a new column, if you will, in the output, not in the physical table itself, but in the output, that is neither name nor the string value. It's something new. It's the combination of this literal and this column. Okay, if we want to give that column a name, we use the as keyword. So we follow the calculation by the keyword as, followed by a column name of our choosing. All right, so I just made up a column name here for our output called product category name. Again, this in no way modifies the physical table or any of the data in the table, right? A select statement only selects data from the table. So now when we look at that output, our column name is product category name. Now this is kind of nice because we can also now sort by product category name. All right, whereas before we would have no column name to refer to in the order by clause. All right, so now, whoops, there we go. I can sort by product category name. All right, again, that's a column that we created in the output, not in the table itself. There's no product category name column over here, right? The data is extracted. Product cat colon is put in front of the name column value, and then once we get the data, it's then sorted by our alias column name. Right? So now it's all sorted in ascending order. Ascending order is the default sort for our current installation of SQL Server. Right, here's another example where we're now using the sales order header table. Right, and we look at the columns in here. We have account number. Right, it's a varchar. Right, and then we have sales order ID, which is an int. All right, well, up here we appended a string, basically a varchar to a varchar. Here we want to append a varchar or a string to an integer column. Well, it's really not possible to do that. SQL Server is not going to convert this integer to alphanumeric automatically for us. So what we do is we first cast that sales order ID to a different type. So inside the cast function, we specify the column name and then the data type we want to convert to. We want to convert it to varchar. Then we can add this varchar to the account number, which is also a varchar, and put this colon in between it. So we're just simply concatenating or adding these different varchars together, and we're going to calculate this entire expression, the account number plus a colon plus the conversion of sales order ID from an int to a varchar, as a new column called calculated column. Let's go ahead and run that. Right. You see in the output, we have account number, a colon, followed by the sales order ID. Right, so far we have worked just with varchar data where we have converted a numeric such as an integer, in the case of sales order ID, to a varchar. But we can also do mathematics here. If we look at the sales order header table, we have a couple of numeric columns in here, tax amount and freight. All right. Let's say we wanted to add those two columns together and have a new column, a calculated column in our output that included both the tax and the freight. And we're going to call that tax plus freight. And again, I just made this column name up. You can call it whatever you want. All right, let's take a look at that. Now I have a new column in my output that is the addition of tax amount to freight, right, for every row in the table, since I do not have a where clause. Let's introduce one more function and calculated field, and this one works with dates. So also in the sales order header table, I have some dates. I have order date, due date, ship date. Okay. So here what I'm going to do is I'm going to select order date and due date, but then I'm also going to, I want to know the number of days difference between the order date and the due date. So I'm going to use the date diff function. The date diff function takes three parameters. It takes the unit of measure, if you will. This can be days, years, months, hours, minutes, seconds. Okay. Well, here I want to know the number of days difference between the order date and the due date. And I want to show that as lead time. Okay? $12 days in a lot of cases. And this might be better expressed as ship date. Might be a better definition of lead time, right? I ordered it on this date, it's going to ship on this other date. That's the lead time. How many days between the date I order it and the date it ships? Okay, and for a lot of these records, it's a week. It's 7. Right? So my column alias is lead time in this particular case. Again, lead time does not exist in this table. It's only in my output as a calculated field. That concludes this demonstration.